Hi, I want to talk about analyzing risk in capital investment decisions. What we've done till now is learn techniques for evaluating whether a project should be accepted or not. So typically we've used net present value, internal rate of return as techniques to evaluate whether you should invest money in a particular project. Now, in every project analysis, what we've done is we've estimated the future cash flows. Now, these estimations obviously can go wrong, right? The fact that you are predicting sales, costs, profits, and cash flows of a particular project for a period of 5, 10 years, and then at times we are also looking at, perpetuities. Uh, it's a given that your cash flow estimation is going to go wrong. So the conditions in the actual market are going to be very different from what you had anticipated in your Excel sheet. And that's exactly what we mean by risk, that there is uncertainty associated with the cash flows that you have projected. Now, there are a few techniques available in finance to try and not account for, but to try and at least evaluate the risk, right? So it's foolish to actually accept or reject a project basis only NPV and IRR calculations, because we know that these NPV IRR calculations are based on projections, estimations, which for sure are going to go wrong, right? Hence, what we want to do is we want to back up this NPV IRR calculation with some risk analysis. And we are going to talk about a few techniques which can help us analyze this risk. Today, what am I going to talk about is a popular technique known as Monte Carlo simulation. Essentially, we can call it simulation. And we want to use simulation in finance in order to tide over risk. Now, I want to take a very simplistic way of explaining simulation as a technique with the help of this case that I am getting through. Let's just read the case first. Let me first of all highlight that where is the risk associated as far as this case is concerned, and how are we going to tide over this risk with the help of simulation as a method. So, we are told here that ABC is considering the purchase of an automatic pack machine to replace two machines which are currently used for product X. So, clearly the decision is that you want to go ahead and buy a new piece of machinery and whether you should invest money in this. Now, obviously when you buy a piece of machinery, it's going to lead to some kind of cash inflows in future. Now, the case says that due to uncertainty in demand, however, the annual cash flows resulting from the purchase of the new machine cannot be fixed with certainty and have therefore been estimated probabilistically as follows. So, if you note, year 1 they have given you cash flows as 10, 15 or 20,000 with a probability of 0.3, 0.4 and 0.3, and hence your year 1 cash flow is not certain. It is uncertain. In year 1 you could end up earning 10,000 or 15,000 or 20,000. There is a 30% chance that you might earn 10,000, there is a 40% chance that you might earn 15,000, and there is a 30% chance that you might earn 20,000. Similarly, in year 2 also the cash flow is not certain. You have 10, 20, 30 or 40,000 with an associated probability given, and year 3 also 10, 20 and 30,000, probability could be 0.3, 0.5 and 0.2. So, this is exactly what I mean, that when you get to real life projections, it is difficult to pin down one number and say, hey, this is what I am going to earn through my project definitely in year 1, year 2 and year 3. That is not how it works, right. So, usually what the project manager needs to do is to generate and curate a probability distribution like this. How do you generate this? By doing a demand forecasting, a survey in the market, and getting to know that what is the probability that your sales will be x, y and z, right. Once you have the probability distribution and the cash flows, the case says that the net cost of the new machine will be 42,000. So, your cash outflow is certain. You know that you will have to invest 42,000, but you do not know what will you get out of it over the next 3 years, right. They have also told you that the cost of capital is 15% and these are the discount factors, right. Now, let us look at these 2 points first and see that how can we look at an NPV calculation and what does a traditional NPV calculation throw up in terms of a decision, right. So, what have I done over here is I have used simple probability to convert the cash flows which are uncertain cash flows into certain cash flows by calculating averages. So, let me quickly go through this calculation. You are told that in year 1 you could earn 10,000, 15,000 or 20,000 with a probability of 0.3, 0.4 and 0.3, alright. Now, if I multiply the probability with the cash flows, what I get is the expected cash flow, alright. So, 10,000 into 0.3, I get an expected cash flow of 3,000, 6,000 and 6,000. If I am going to add up all of these three, right, I will get an expected cash flow of 15,000, right. Let me color it differently so that it is visible, 15,000. So, what do I call this? I call this as the expected cash flow or the average cash flow from year 1. So, on an average year 1 is likely to earn a cash flow of 15,000. Similarly, year 2 the cash flows multiplied by the probability and then adding up these expected cash flows, what do I get is an expected cash flow of 28,000 and year 3 I get an expected cash flow of 19,000. So, now after converting the probabilities into averages, the project reads as follows: on an average year 1 I will earn 15,000, on an average year 2 I will earn 28,000 and on an average in year 3 I am likely to earn 19,000. If I discount this at a PVIF or a cost of capital of 15%, my present value of expected cash flow is 13,000 plus 21,000 and plus 12. If I add all of that together, what do I get is an expected present value of cash inflow as 46,000, 42 is my cash outflow, the cost of the machine, and hence inflow minus outflow in present value terms gives me an expected NPV of 4,708. Now, I hope you notice the use of the word expected NPV, because this NPV is calculated on expected cash flows, which is average cash flows. I will have to say that on an average my NPV is likely to be 4,708, and hence I hope you get it. We do not have a very, if I were to place a confidence level on this NPV, I do not know what is the degree of confidence that I have, because I am saying on an average the NPV is likely to be positive 4,708 and hence you should accept the project, but I do not have a degree of certainty associated with this. That is where that's where the technique of risk analysis comes in, and I want to analyze that what is the risk associated with this project and will I really get a positive NPV, because if my probability distribution changes a little bit over here, then I hope you get it, my averages will change, and if my averages changes, my expected NPV could be negative as well, right. And hence as a project manager, I am not too convinced taking a decision by placing all my bets on this one amount of 4,708 and saying, hey, let us go ahead with this. Why? Because it results into a positive NPV. The word expected NPV or on an average the NPV will be 4,708 is something that stops me from going ahead and taking that call.